Number 5. Children and sled with mass 50 kg slide down a hill with height of 0.46 meter. If the sled starts from rest and has a speed of 2.6 meter per second at the bottom, how much thermal energy is lost due to friction? How much thermal energy is lost due to friction? What is the work that friction does? Okay, or what is the work that friction does? Okay, and then if the hill has an angle of 20 degree above the horizontal, what was the frictional force? Okay, so dia ada energy loss due to friction. So kita boleh apply conservation of energy with dissipative forces. Okay. Total energy initial plus energy loss equals total energy final. Okay, so sebab soalan ni nak energy loss, energy loss due to friction, so maybe kita boleh jadikan energy loss as a subject. Okay, so energy loss equals to total energy final minus total energy initial. So we have to identify what kind of energy at initial position and at final position. Okay, so children ni dia slide down a hill. Okay, ni hill. Okay, dia slide down sampai bottom of the hill. Okay, bottom of the hill. So this is the chalk. Okay, this is the chalk at the bottom. Initial dia dekat height 0.46 up the hill. And then they slide down the hill sampai bottom of the hill. Okay, ni final position dia. Okay, so dekat final position, dia dekat ground level. Jadi, dekat final position, dia tak ada potential energy lah. U final dia tak ada. And then, dia moving. Dekat final position moving, jadi dia ada kinetic energy final. Okay, ni dekat final. And then, dekat initial, kat sini. Dekat initial, dia at particular height from ground level. Jadi dia adalah potential energy initial. And then dia kata sled start from rest. Jadi kinetic energy initial dia tak ada, 0. Sebab dia tak moving. Okay, so kita dah boleh cancel kinetic energy initial. Okay, kosong. And then dekat final kita boleh cancel potential energy. Okay, sebab dekat ground level. And then kita boleh substitute, kita boleh tulis formula bagi kinetic energy final adalah half mv squared, dan formula untuk potential energy initial adalah mg height initial. Okay, dan kita boleh substitute mass of the children and the sled is 50. And then final speed dia dekat bottom of the hill is 2.6 squared. And then minus in bracket, ini mesti dalam bracket, mass of the children and the sled times g 9.81, and then height initial. Okay, height initial 0.46. Okay, so kita boleh dapatkan nilai dia 0.5 times 50 times 2.6 squared. Okay, dapat answer baru tolak dengan dalam bracket 50 times 9.81 times 0.46. Okay, tutup bracket. So, dapat negatif 56.63 joule. So, dapat negatif. Work is done by the system to overcome the friction. Okay. Work is done by the system to overcome the friction. Okay. And then yang kedua, dia tanya frictional force. Okay. First, dia tanya energy loss due to friction. Yang kedua adalah frictional force. Okay. Frictional force berapa? Okay. Frictional force berapa? So, untuk yang ini, kita boleh guna formula work done by friction equals to friction dot S. Okay, work done by friction equals to friction dot S. Yang mana work done by friction adalah sama dengan energy loss due to friction. So, equals to negative 56.63 joule. And then, kita boleh ganti dekat sini. Okay. And then, friction unknown yang kita perlu cari. And then, displacement S. Displacement S. Berapa displacement S? Okay, berapa displacement S? Okay, displacement S adalah dekat sini ni displacement. Displacement S. Okay, so displacement S ni kita boleh cari daripada trigonometry. Okay, bagi angle above the horizontal kat sini angle 20 degree. So, kita boleh guna trigonometry. Okay. Maybe sin 20 degree equals opposite. Okay, opposite adalah H. Okay, opposite adalah H. Okay, H. And then over hypotenuse. Hypotenuse adalah S. Okay. So, kita boleh gantikan H 0.46. And then S ni adalah unknown yang kita nak cari. So, S equals to 0.46 over sin 20 degree. So, equals to 1.34 meter. Okay. So, the children move with displacement 1.34 meter. And then, kita boleh substitute lah dekat dalam formula work done by friction. Okay. Work done by friction equals to friction dot S. Okay. Okay, friction dot S. Yang mana kalau kamu tengok kat sini, friction, arah friction adalah di sini Ini arah friction. Jadi angle antara friction dengan displacement adalah 180 degree. Okay, 180 degree. degree. Okay. Okay. So, kita boleh gantikan work done by friction equals to friction cos theta times displacement S. Work done by friction sama dengan energy loss sama dengan negative 56.63. And then friction is the unknown that you have to find. Theta antara friction dengan displacement adalah 180 degree. And then displacement adalah 1.34. So, kita akan dapat frictional force. So, negative 56.63 divide with cos 180. Okay. Divide with 1.34. So, dapat friction equals to 43.26 Newton. Okay. Okay, unit untuk frictional force adalah Newton. 42.26 Newton. Okay.